Class, we are now on 10.2, the law of cosines. Now, the law of cosines sounds quite similar to law of sines. And in the ends, yes. The ends are that if you have a non-right triangle, which we've been dealing with law of sines, you both have non-right triangles, so they could be 92 degrees. One of the angles, they can be 87 degrees. Anything other than a 90-degree right triangle. You can use the law of cosines to find any side or angle measure. But what's happened this time is, what if you weren't given a complete ratio of an angle across from a side like you would need for law of sines? If you weren't giving any of those, then you cannot use the law of sines because you would have too many variables to solve for, and you can only solve for one variable given what you know. So in some cases, say I know this side is 10. So this side is, it's 10. This side is 15. And I know this angle, oops, I better put it right there and it'll go hopefully into the spot here. This angle is 33 degrees, okay? If I have that much information, I don't have enough. In fact, I'm just going to draw it here because I know it's not going to move. If I know this side is 10, this side is 33 degrees, and this side is 15, I don't have another angle that is across from any of the sides. I don't have any sides across from any angles, and I can't come up with them because I only have one of the three angles, and I have no idea what another side would be. And if I have that scenario, then I cannot use the law of sines. Law of sines isn't going to help me, which is unfortunate. All right, I just can't use it. Or if I have another triangle of side, 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 so I know this is 10, this is 15, and this is 30, or I better say 3. Let's say it's, well, it can't be 3. Say it's 8. Okay, so 8, 10, and 15. Not a right triangle. I don't have any of the three angles, and I cannot use the law of sines. So side, angle, side, or side, side, side. Do you remember those from geometry? I hope your teacher said, oh, you're going to need these next year, because you will. All of this law of sines, law of cosines, and trigonometry is based on those scenarios. So we have side, angle, side, and side, 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 where we can't use the law of sines. So we are given the law of cosines instead, which is good because then we can indeed find the other sides and angle measures for the triangle. But it's bad because they're not as easy as the law of sines. So if we have to resort to the law of cosines, it's because we need the sides pretty badly, but we can't find them any other way. So I don't know how to hit back from pen. Oh, I guess I just hit that. All right, I'll try that next time. All right, so the law of cosines are, you have 3 of them because it's dependent on the side and the angle that you have. All right, it's unfortunate. But here we go. So, and there's a pattern, so I'll help you with the pattern. A squared equals b squared plus c squared. It's based on Pythagorean theorem. Sometimes in my classes I have derived the law of cosines, but I'm not going to here. 2bc times cosine of a. Okay, now what you notice that to be, this in this case would be a, little a, and this would be angle a. So what it is this side squared, the side across from the angle you know, is equal to the sum of the square of the other two sides. It's almost like it starts out like the Pythagorean theorem. A squared equals b squared plus c squared, so the other two sides, minus twice 10 times 15, b times c, times the cosine of the angle across from the side that it's a squared. So a squared and a are the sides across from each other from the angle. They're the angle and side across from each other. All right, and that happens with the next one. You have b squared is equal to a squared plus c squared minus 2ac times the cosine of the angle across from it, b. And then c squared is equal to, you could probably know this by now, a squared plus b squared minus 2ab times the cosine of the angle c, which is across from little c. So those are the law of cosines. They even get more tricky when you're trying to solve for the angle. In this case, you're going to have to look for an angle instead because you're given the three sides and you can't find it any other way. So those are the law of cosines. All right. I memorize it by position. So the side squared is equal to the other two sides squared and summed minus 2 times each of them times the cosine of the angle across from it. So here's my angle and here's the side across from it. Okay, I figure out those first. And then I don't even have the formula in front of me. So hopefully you guys can get to this point where it's location. Your side opposite, x squared, is equal to 9 squared plus 23 squared, the other two sides squared and summed, minus 2, remember that minus 2 times 9 times 23, the two sides, times the cosine of the angle x, which is 71 degrees. So you set that up every time. And if you can remember that location, then it's really easy when you're setting it up. Now, the trick is, I'm going to show you in my calculator, and you're going to be like, wow. I'm going to even use the calculator that you would most likely have. There's this little thingy in it. Oh, well, I'm not getting it out. Oh, well. All right. Where is my image here? Here we go. Okay. Whoops, I need to see it. So I'm going to kind of put it right here. Can we see that? All right, what I'm going to do is I'm going to place this in the calculator. If x squared is equal to that, then I need to square root all of this, right? Oops, pen. I need to square root all of this. Well, square root both sides. So it'll be x is equal to the square root of 9 squared plus 23 squared minus 2 times 9 times 23 times the cosine of 71 degrees. So I went to put that in calculator and remembered, oh yeah, you can't just place that in the calculator because you don't have x equals. You need x equals to be able to do that. So, which makes me even have to put this down lower. Hopefully we can see this if I put up one side so the glare's gone. All right, so you're going to do square root, and you're going to just plug this all in the calculator just like you see it. 9 squared plus 23 squared minus 2 times 9 times 23 times the cosine of 71. All right, and you don't have to arrow out. It's all underneath that radical, and hit enter, and it does all the work for you, including all of the, please excuse my dear Aunt Sally, and making sure everything's done appropriately. And you are found the side now, 21.8. Nearest tenth is 21.8. All right, so 21.8 is what x is approximately. Again, we're dealing with radicals, irrational numbers, so we don't know for sure all it is, but we know it's approximately 21.8. All right, and that's what you're going to do every time. It's pretty exciting. You just plug it in your calculator, but just write it out and memorize how to write it. That's the trick, is memorizing how to write it. So here we have the side opposite and the angle. And we see we have side angle side, so that's a hint to us. Wow, that went way far down there. Side angle side is what we know we have. So then we think, oh, law of cosines. We have to use law of cosines. So we do x equals, and we're just going to solve it with the square root. Okay, so x equals square root of 15 squared plus 17 squared minus 2 times 15 times 17 times the cosine of x, which is 39. It's just the angle across from little x. All right, go back to our calculator. And in our calculator, sometimes I even just go up and extract it, hit enter again, just change the angle to 39 because it's already in there. Negative 2 times 15 times 17. All right, and then we need 15 times 17 over here. So 15, oops, I went too far. 1, 5 squared plus 17 squared. All right, I probably could have typed it in faster, but I am going to check it. That one out there is not going to matter, so I know it doesn't really, shouldn't be there, but it is, and I don't want to go back and fix it. So I got everything typed in, 10.85, 10.85. So 10.8 is what x is approximately. That means this side is approximately 10.8 units, whatever the units are. All right, so do I have time to do one more? Yeah, I probably better. All right, so in example 3, you have everything there. Does it say find each missing measure? So x, it doesn't mean solve the whole thing. Yeah, it just means just find AC. So what you're going to do is you're going to draw a triangle ABC. Now, it doesn't matter where you put the A and the B and the C as long as you set up where the appropriate measures are. So if it says measure of angle B is 106, you want to make sure you put that at angle B. AB, side AB is 10, side BC is 7, and you're asked to find AC, that side right there. Okay. So that looks like this is all set up perfectly. You have the angle 106 right here and the side x that you're looking for. So x is equal to the square root of 10 squared plus 7 squared minus 2 times 10 times 7 times the cosine of the angle 106 degrees. Now, last time when I put this in the calculator, I probably shouldn't have done what I did, so that was kind of silly. I'm going to just plug it in as I see it and not try to come up with finding it before. It just took too long. So square root of 10 squared plus 7 squared minus 2 times 10 times 7 cosine 106 degrees. All right, and that is 13.7. Now, I didn't do my usual and check, make sure everything hit in correctly, but 13.7. If I did, let me know. I'll remake the video, but 13.7 units is what that side would be. All right. All right, I'm going to go ahead and stop there. Actually, do I have time for one more? It might help if I have one more done. Let's do one more. So these are side, side, side. So here we have an issue because we have side, side, side. Okay, side, side, side means that when you plug it into your formula, this is the side opposite the angle. You would have 8 squared equals, and then you have the other squares, 10 squared plus 11 squared minus 2 times 10 times 11 times the cosine of x degrees. That means you're looking for an angle. All right, now in order to do that, you need to figure out what cosine inverse is. So we have to solve for the cosine inverse. I'm going to subtract 10 squared and subtract 11 squared from both sides. So I have 8 squared minus 10 squared minus 11 squared is equal to negative 2 times 10 times 11 cosine of x degrees. Okay, so stick with me here. I need to get cosine x degrees alone. So I'm going to divide by negative 2 times 10 times 11, both sides. That gets rid of everything and says cosine x degrees is equal to 8 squared minus 10 squared minus 11 squared over negative 2 times 10 times 11. Now, I know this sounds crazy, but I'm going to just plug that into the calculator to figure out what that is, but I do need to see it. Okay, what you're going to do, because you're looking for the angle, you're going to do second cosine, because that allows you to find the angle. Second cosine, hey, I got a little spot in there that works. And then do your n over d, and do 8 squared minus 10 squared minus 11 squared over negative 2 times 10 times 11. Arrow out and put your parenthesis around that. So that's all cosine inverse of all of that. Hit enter, and you've got it. It's 44.5 degrees. And that's your angle. All right, we'll stop this here, and then we'll move on to the next one, part 2 for the rest of these.